Hello everyone, today let's solve the problem number 647, palindromic substrings, right? So what the question states here, we are given a string S. You can clearly see here, we have been given a string S, right? So how many palindromic substring it contains? We have to count how many palindromic substring it contains. So we have to count how many palindromic substring this string contains. S, the string S contains basically, right? So a substring is a contiguous sequence of characters and a palindrome reads the same backward as forward. A substring is nothing but contiguous sequence of characters. We can clearly see here A, B, C, AB, AC, so BC, BA. So these are the substrings, right? A substring is a contiguous sequence of characters and a palindrome reads the same backward and forward, right? Palindrome reads the same backward and forward. Suppose for example, MAM, M-A-M, right? So it reads the same backward and forward. A single character is always said to be palindrome. Just remember this. An empty string is said to be palindrome. A single character is always said to be palindrome, right? So when we read the same thing, we have only one character, right? So we have only one character. A single character is always said to be palindrome. Just remember this one as well. As well as just remember this one as well. Empty string is always a palindrome. Just keep this in mind, right? So this is what they have asked us to do. Basically what we need to do, we have to count how many palindromic substring it contains. So let's consider the first example here, ABC, S equals ABC, right? So here the output we have got as 3. Here we have 3 different characters, right? A, B and C. So palindromes that can be formed here as single character. Single character is always a palindrome. We have already discussed this one, right? A, B and C. So other characters, other substrings are AB, BC and AB and BC, right? So and ABC also we can consider the 3 characters at a time. So nothing forms a palindrome here except A, B and C, single character. So we have to return 3 in this case. So we have to count the number of palindromic substrings it contains, S contains basically, right? Here in this case 1, 2, 3. So we have to return 3 in this case, right? Let's come to the second example here. We have triple A. We have triple A here. So one thing here is A. These are 3 different characters, right? So these 3 forms a palindrome. So third one is double A. So the first 2 letters we can consider. Fourth one we can consider here as, fourth one is this one, double A. The fifth one is also double A, second character and the third character, right? So the sixth one is AAA. So when we read backwards, it is same, right? So when we read from backwards, it is same. AAA we can consider, as we are having the same characters. We can find 6 palindromes, right? We can find 6 palindromes here for this particular example. So this is 4, 5 and finally 6, right? So we have to return the count, right? So in this case, we have to return the output 6. So you can just count here 1, 2, 3, 4, 5 and 6, right? So I hope the question is completely clear. What we need to do is completely clear as well. Simple, right? So let's do one thing. Let's discuss the approach first, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. So first thing that we need to note down here is we will be going with the dynamic programming approach. So we'll be going with the DP, right? So just keep this in mind for the memorization purpose, right? So I have considered the first example, the same example that they have given in the this one question, basically the first example, right? So here we have already discussed this one, A, B, C. We have 3 different characters in this case. The only palindromes that we can form here is within the substrings is single character, is of the single character A, B and C. So we need to return the count. In this case it is A1, B2, C3. So we need to return output as 3 in this case. So that's what here we have returned 3, right? That's how we got 3. Let's move on with the step-by-step execution here. So basically what happens here is, just give me a second here. So we are going with the first example itself, right? A, B and C. So here in this case, length we have is 3. So I goes from, here in this case, I goes from 2 to 0 and J goes from 2 to I, right? So I goes from 2 to 0 and J goes from 2 to I. So we have considered here I 2, 2. So 1, 1, 1, 2, 0, 0, 0, 1 0 2, right? Different combination. So here in this case, 0 is nothing but 0th index what is present, A, right? So 1 is nothing but B, and 2 is nothing but C is present, right? So we are trying with different combinations here. S of I we have as 2, we have C, right? Here I is C and J is also C. In this case, J minus I is 0, right? J minus I is nothing but 2 minus 2 is 0. This is fine. So in this case, whenever we get 0, it is true, right? Whenever we get 0, we get the output true. So here we are considering 1 1. 1 we have B here. See, 2 we have C, 0 we have A, 1 we have B, 1 1, B B, 0 0, because it is 0, dp of j is true in this case, right? Same, let's do the same for everything here. Let's do it very quickly. 1 and 2. 1 we have B and 2 we have C. See, so this is palindrome. CC we know. When we read backwards, it is same. BB is also palindrome here in this case. BC is not a palindrome, right? So BC is not a palindrome. In this case, we will return this one 1, not 0, because it is false. Because it is false, right? So this is fine. J minus I is nothing but 2 minus 1 is 1, right? So fourth one 0 0 we are going. 0 is nothing but A. We have 0 here. 0, as we have got 0, we'll go with true. Here in this case, A and B, by 0 and 1 we are considering 0 A, 1 B. Here in this case we got 1 and the output is false. This is fine. The this one, the last one is 0 2. 0 is nothing but A. Here this one 2 is nothing but C. So again, this is not a palindrome. This is not a palindrome. This is not a palindrome. BC is not a palindrome. These three, right? True true. This one is again false, right? So these three are true. AA, BB and CC. Right, here in this case, let's consider CC, BB and AA, which are palindromes. Basically, palindrome C we have considered, CC as it is C. BB, B we have considered, and AA we have considered here. Count when we got C, which is different basically. 1, when we got BB as a palindrome, we will increment the count. Now the count is 2. So when we got AA, the different one, C is different from B, B is different from A, right? So A is different as well. So when we get A as palindrome, AA, true, value true, we will increment the count. Here in this case it is 3. So for the other 3, will not be doing anything. So here in this case it remains true itself. After 3 we do not have any palindrome, so we keep the count same itself. So the last one, the number that is present at the last cell, will return the same thing as output, this one, last one, right? So 3 we have got here in this case. So output will be 3 in this case. The output that we got here is 3, which is equivalent to the output that they have given for the example 1 in the question, right? So the output that we got is equivalent to the output that they have given for the example 1. Now the approach works absolutely correct in this case, right? So now we are completely familiar with the approach. As we are completely familiar with the approach, let's discuss the edge cases quickly. So the first edge case is for the single character, right? We have the single character here. So output is quite obviously in this case for the single character. So I have considered here this one, right? 3 different. So this has to be single character. Sorry. Let's consider A here in this case. So output will be 1 in this case. So let's go with the single character. I got confused here. I think I took wrong string here. So single character, we will be going with A, and the output will be quite obviously 1 in this case, right? There is only one character, so it is a palindrome. So we'll be considering output 1. One single character equals 1 palindrome. We know this one, right? Let's go with the second edge case here. All same. All same means all the characters are same. Here we have 3 characters basically. Length is 3, but we have the same characters A, right? So we have already seen this one. So the palindromes that can be formed here is A. This one 1, 2, 3 different. Then first 2 we can consider A. Then 2, 3 we can consider A. Then finally all the 3 A, right? So these are the palindromes, totally 6. So output is quite obviously 6. Let's move on with the third edge case, no repeats. We have ABC, the approach one, right? The first example that we considered, same thing here. The output is 3 for this one. We have already discussed this one. We don't have to discuss this one again. No repeats. So let's move on with the fourth one, palindromic word. Palindromic word we have here as ABA, right? So when we read backwards, this is same. This is the palindromic word total, right? So we can go with A, B and again A. This is different one, and the palindromic word ABA. These are the 4 different palindromic substrings, right? So in this case, we have to return 4. Let's move on with the final edge case here, long unique, right? Long unique. So in this case, A, B, C, D, E, F we have. So all the letters are unique here in this case, right? All the letters are unique in this case. We can form only palindromes that can be formed here as the individual characters, nothing but A, B, C, D, E, F in this case, right? A, B, C, D, E, F in this case. So these are the 5 edge cases that we need to keep in mind. First one is for the single character, second one is for all same, third one is for the no repeats, fourth one is for the palindromic word, fifth one is for the long unique characters. Long unique string we can consider. Yeah, these are the 5 edge cases. Now we are completely familiar with the edge cases as well as the approach. We are good to write the code. Let's start writing the code. So the first step here is let's get the length of the string. So we'll be making use of the length of the string many times. So I'll just assign this one to the variable n here. In this case, s dot length. This is fine. Let's move on with the next step here. Let's as I have said, we will be going with the DP. During the approach, I have said the same thing, right? Alright. So let's create the 1D DP array to track the palindrome that ends at J basically. So we saw the step-by-step execution I and J, right? So let's create a 1D DP array now. So I'll just go with the boolean basically. Let's consider the variable DP. Let's create the boolean of n. We have considered n, right? Length as s dot length means length of the s as n. So this is fine. So let's initialize the count of the palindromic substrings. Initially, I'll just go with the variable count and let me initialize this one to the 0. So the first step here is we have to loop from right to left, nothing but the start index. We are traversing from right to left, right? Again, reverse iteration. We can just call this one reverse iteration. We are looping from right to left as well as we are looping from right to I as well. Right to I, these two things we are doing. I and J we are considering, right? So we have idea on this one because we have seen the step-by-step execution. This will be reverse iteration n minus 1 I greater than or equal to 0. Let's increment the I here. For the J, I'll just go with int J. Sorry, did I forget the parenthesis? So I'll just go with int J equals n minus 1 J greater than or equal to I. So let me decrement the J here. This is fine. So the next step is within the for loop, what we need to do here, if the characters at I and J match. So if the characters at I and J match, then what we need to do within that condition, if it's a single character or two same characters, then it is said to be palindrome, right? So first, if characters at I and J match, right? So for that one, I'll just write a simple if condition here. Is I'll just make use of the caret here. Caret at I, same goes with, we will compare again s dot char at J. So if character at I and J match, that's what we are checking, right? Simple one. So within the if condition, if it's a single character or two same characters, then it's said to be palindrome. Again, within the if condition, we'll write one more if condition. J minus I is less than or equal to 1. Means if it's single character or two same characters, then it's said to be palindrome, right? So if it's said to be palindrome, then we have to make dp of J, we have to assign this one to be true. Means we are just saying it is a palindrome, right? If it's a single character or two same characters, then it matches, right? When we read the same backward from backward as well, the letters, right? When we read from backward as well, then it is said to be palindrome. To be palindrome, we have to assign the dp of J to true. Else, if it is not a palindrome, so else if the letters or the word if it is not a palindrome, then what we need to do, we have to check the inner substring, nothing but from I plus 1 to J minus 1. I can write it on this way. Else I'll just give here dp of J, I'll assign this one to the dp of J minus 1. So this is fine. Else what we will do, so this part, so this is not for the basically not a palindrome. So this is for the condition we are checking the inner substring I plus 1 to j minus 1. We are checking for all the inner substrings, right? So if whether it is a palindrome or not. Now we are writing for the basically line number 16 I'm speaking of. Now we are writing whether if it is not a palindrome. If it is not a palindrome, then we will assign dp of j to the boolean value false, right? Simple. So the next step here is, let me come out of this. If it is a palindrome, then we have to increment the count as well. So if it is a palindrome, A is a palindrome, B is a palindrome, C is a palindrome here. So A is a palindrome. Next, when B is palindrome, we have to increment the count to 2. When C is a palindrome, we have to increment the count to 3. That's how we got the output 3 here in this case, right? So we have to increment the count here. So I'll just write the simple if condition again here. If dp of j, then if it is a palindrome, then we will increment the count here. Simple. So the final step is we have to return the count, or we have to get the final count, right? So we have to return the final count as output itself. So in this case, I'll just go with the return. The variable I have considered as count itself. So I'll just go with return count. Nothing but we are returning the final count here on this step. So let me format the code once and let me hit the run button. So this is it for the code. Let's see whether this works or not. So we have the, so I have misspelled boolean here, line number 4, boolean. So let me give a here. So let me hit the run button here. So yeah, now you can clearly see the sample test cases are getting passed. Once the code works absolutely correct on this case, right? So let's see whether this works for all the test cases or not. So let me do one thing. Yeah, let me hit the submit button. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct on this case, right? So I hope whatever the code that we have written is completely clear as well. So now let's discuss the complexities very quickly. Complexities for the code that we have written very quickly, right? So the approach that we went with here is this one DDP with reverse traversal. Nothing but we can just call this one as dynamic programming, right? This is fine. So what is the overall time complexity here? The overall time complexity here would be big O of n to the power of 2, big O of n to the power of 2 or n square, because we are making use of the nested loops here. You can clearly see here we are making use of the nested loops. I'm speaking of line number 7 and 8, right? So we are making use of the nested loops, which basically checks every substring pair I comma j, where I less than or equal to j. We know this one, right? So we have discussed this one completely till now. So overall time complexity would be big of n square. So what would be the space complexity here then? So overall space complexity would be big of n. So why it is big of n? Because we have only one d boolean array. Means dp, this one I'm speaking of. Where it is, the line number 4. We are having only one this one d boolean array dp, which is of size n. Here we have passed n here, which is of size n. Basically we are using this one dp array to store the result, right? So overall space complexity would be quite obviously big of n in this case. In the worst case, we know this one, right? So the space complexity would be big of n in this case. So the time complexity and the space complexity for the code that we have written as big of n square and big of n, right? I hope the complexities are clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching.